does humidity affect respiratory aerosol? Well, this means that we are interested in the hygroscopicity of the aerosol. This is one of those weird science terms that simply means how much water does a chemical pull out of the air. When it comes to aerosol science, it's represented by a graph such as this. This is called a hygroscopic growth curve, and it describes how an aerosol changes size by picking up water at different relative humidities. The way you read this graph is as follows. Let's say you have a wad of respiratory fluid. Now, take away all of the water, which leaves you just a mixture of salts, proteins, sugars, and surfactants. If you were to make a 1 micron aerosol droplet of this mixture, and then suspend it in air at 50% humidity, the diameter of this aerosol would be 1.1 microns. If you were to raise the humidity to 90%, the aerosol droplet would be 1.5 microns. And if you raise the humidity again to 95%, it would be 1.9 microns. Now, the utility of this curve is that this ratio is constant, meaning if you took a 2 micron aerosol droplet of water-free respiratory goo, an identical relationship would be seen. So at 95%, the aerosol droplet would be 3.8 microns. At 90%, it would be 3 microns. And at 50%, it would be 2.2 microns. All right, so the hygroscopic growth curve is really a useful tool that we can use to predict how respiratory aerosol changes size in different conditions.